So to decrease the frequency, we can either increase the number of stages or increase the load capacitance. For the first option, we know frequency equal 1 over 2 multiplied by the number of stages multiplied by delay time, which we have already measured. So for a given frequency, we need to find n, and n should be odd number. For the second option, we need to follow some extra steps to know what exactly the capacitance we need to add to have a given frequency. Okay, we have already a frequency we have measured before for just inverters, no extra load capacitance. But we don't know what is the value of this parasitic capacitance. So we are going to add a capacitance that is larger or bigger than the parasitic capacitance that is contributed by the inverters, and measure the frequency for this extra cap, and we are gonna have this relation f1 by f2 equal td21 by td1. We already mentioned before that the delay time is a function of r and c. Since we haven't not changed any sizing, the r is the same, so they are going to cancel out, and we have just the c. The second cap is the total capacitance, the capacitance we have added before, and the parasitic capacitance. Then we need to get this C1. Now after we have C1, we can have this relation F1 that we already have, which in our case is 26.6. If required, if we need to get C1, the cap we have measured, and this is the parasitic caps added by the inverter, plus C added the one we had to get this frequency over the C1. I know this point may be a little bit confusing, but when we try it, you will see it's very easy. So what I'm going to do, I will go to the simulator and I will add 10 femtofarad in order to measure C1. Then I will do some calculations to know which cap I should add to get 5 gigahertz output frequency. So let's back to our simulator. Okay, let's add 10 femtofarad here. Cap. Okay, let's move this sig out to the calculator and measure the frequency. Frequency. Okay, we need to add this to the outputs also because we'll need it later. get expression, frequency, add. So it is 2.6 gigahertz. Okay, so let's back to our paint and do some calculations. So this empty, let's empty this. Okay, so the F1 we have already measured is 26.64, and the second frequency we have measured is 2.61, right? Is equal to C1 plus C parasitics, which is 10 femtofarad, by C1. So we need to find this C1. So if we do some calculations, C1 is equal to, let's calculate it, which is equal to 1.087 femtofarad. So what is the capacitance we need to add to have output signal of frequency 5 giga? So 26.64 over 5 giga equal to, so we have a known frequency over if required equal to C1 plus added capacitance to get this 5 giga, or if required, over C1, the C that, and this C maps to the parasitic capacitance of the inverter. So F known is 26.64, and this if required we need it 5 giga equal to 1.088, we have already calculated, plus C added. We need to know what is the value of this added cap. So let's repeat our calculations. 6445 multiplied by 108. So according to my calculation, in order to have 5 gigahertz frequency, we need to add capacitance of 4.7 femto. So let's reduce this cap to 4.7 and repeat our simulations. Okay, and here is 5 gigahertz, so the calculations are correct. So let's get back to our PDF because there is some points I need to highlight. So a ring oscillator, just inverters, no any added loaded capacitance. It has a fan out of 1. What is the fan out? Fan out is a ratio between load capacitance and the gate capacitance. So in that case, our inverter is loaded by gate capacitance of this device, which is the same as its input capacitance or gate capacitance. So it has a fan out of 1. The width of this device, nothing will change. The delay is the same, the frequency is the same because we increase the current and we increase the capacitance as well, two opposing effects. But if we increase the length, the current, the charging current decreases and the capacitance increases, which increases the delay time and hence decreases the frequency of the oscillator in two directions. So increasing width, resistance decrease, capacitance increase, but the delay is the same. Increasing the length, resistance and the capacitance increase and the delay time increase as well. This is the case if we have no any load capacitance. But what if we have load capacitance here? If we have a cap bigger than the parasitic capacitance and the parasitic capacitance is neglected and the parasitic capacitance is neglected compared to the load capacitance, increasing the width will increase the frequency because in that case the charging current increases but the load capacitance or the total capacitance is almost the same because the parasitic capacitance is very small compared to the load capacitance, so the load capacitance is still the same but the charging current increases. Let's back to the simulator to check this point. So let's have here 10 femto, which is 10 times the parasitic capacitance. We knew before that the frequency is 2.6 giga, right? Let's double check. Yes, it is 2.6 giga. If we double the width of this inverter, the frequency will double too. So let's go to the multiplier, 2 multiplier, 2 multiplier. Okay, the frequency is 4.7, which is nearly the double. All for okay, that's all. If you have any questions, please let me know. Thank you.